the reason we switch from paper maps to the digital version just because it's transformed our way to navigate. And as a users, for us, it's much more easier right now to create the route from point A to point B just in a couple of seconds. And as a result, it's increased our productivity as a users. And that is my today's speech is about. How to increase the user productivity and switch from manual to intelligence workflow. And my name is Marina Petzel, and today I will talk about 3 topics. First one, what is the difference between horizontal and vertical AIs, and what are the main challenges for them? Then I will talk about how to collect and label data for the vertical AIs, because that is a niche which I represent with Autodesk, and also how to develop and maintain very powerful AI models for vertical AI tasks. So, before we start talking about my presentation and my key points, I want to start with a short introduction slide. As I already said, my name is Marina Petzel. If you also struggling remembering names as I do, I prepared the visual representation of my name. Oh, and it's not show off. I don't know why. So here it's supposed to be 2 emojis. The first one is boat, Marina, it's a home for boat, and Petzel is like pretzel without an R. So if you have ever seen the boat full of pretzels, please let me know. I'm a senior machine learning engineer at Autodesk, and before I have my background in computer science and data science. Before I joined Autodesk, I used to work for healthcare industry in UCLA, where I did my research on predicting the mortality after the surgery for the patients. And as a result of this research, I was published in the scientific journals like Nature Journal. And also in my free time, I also tech influencer in social media. And actually here today there is like one of my followers. And it's so excited to talk about AI and data science and help young professionals to start their career there. And here it is, my emoji, boat and pretzels. Yeah. Okay. I hope you also heard about Autodesk. If not, and maybe some of you use our software products, Autodesk is a leader in design and make software. We develop more than 90 software products and have over 100 million of users around the world. And to understand better what type of products are we developing, we represent our products in multiple industries. Architectural engineering, construction, manufacturing, and media entertainment. And if you can, as you can see from the last image on this slide, we used one of our software to build one of the recent Lion King movie. So we make quite a bit different software products. And today I will talk about AC, Architectural Engineering and Construction Industry. And before I start talk about that, I want you to understand what type of users we work with. Our users are architects, project managers, engineers, and everything, and other professionals, and we helped them to create designs to build the buildings or different manufacturing things, as you can see here. Well, and when our users, for better understanding what type of drawings our users work with, I want to show you this drawing. So, if you have ever looked for real estate, you've probably seen similar drawings. So it's the main locations of the rooms, main objects there, like, I don't know, chairs, tables, and everything. But this type of drawing is considered relatively simple. And just imagine when our users have to deal with something more difficult, like this floor plan. That's getting much more complicated, right? And just imagine if the user who works with such type of drawings, which are quite common in the industry, just imagine if the user needs to replace or insert some of the objects there. That's getting very, very hard. And our team started to brainstorm how we can leverage machine learning and AI to simplify this process. And now I want to show the random snapshot from the previous drawing, which probably takes, I don't know, it's probably less than 1% of the entire drawing. And at least on that snapshot, I can see 5 different types of chairs. And just imagine if the user needs to replace some of them. It might be many different reasons, I don't know, manufacturing shortage, or just they need to change the design. And what options does the user have? Actually, browse manually within the entire drawing and find the right one, or browse between the different old drawings that they used to have, or browse the internet. So all in all these scenarios, it will take a lot of time for the user to get the right one and replace the object. And as a result, it's obviously getting very inefficient and very time-consuming. And addressing this problem, we start to think how we can automate and optimize this searching process and enhance the user productivity. And that is where intelligence workflow comes into play. And I just want, before I start talking about how we do that, I want to show you the quick demo, how actually we did it. Hope it's playing. Button there? I'm not sure. Probably not. That's fine. So, I have a demo today. But how it works, what I wanted to show, that users select the random object on the floor plan and click the button, and then the tool will suggest the user similar objects, like different types of chairs. Yes, and that is how we did it. So believe me, it works that way, and we realized that if we will give this automation to our user, and user can still have a full control and can manage the workflow, it empowers our user and saves a lot of time on the common tasks, and the result increase their productivity. And now let's dive in and talk about how we did this project. So, like in any other machine learning projects, the first step, of course, is the user data. And remember, I already mentioned that earlier I used to work in healthcare industry. And one of the biggest challenges that we faced at that time was the lack of sufficient data. And fortunately, we have much more healthy patients rather than sick ones, but it was very tough for us to gather a sufficient amount of data to do the reliable research. And that is the same, that is the challenge that we faced in our project too, how to collect the industry-specific data. And data collection issue is quite common for vertical AI tasks, and which intend for specific industries. And just to refresh your memory, I want to quickly review what is the main difference between horizontal and vertical AIs. Well, horizontalize is the great for general purpose tasks, making it highly versatile. And right now, there is no difficulties to distinguish cats and dogs on the image, right? Of course, there are some tricky scenarios, but still, it's pretty easy to do. However, general purpose tasks and horizontalize are not optimized for industry-specific data like healthcare or architectural industries. And that is where vertical AI comes into the play. Vertical AI is designed for specific industries and tasks and boosting impressive accuracy if you will fine-tune your model fair enough and making it more efficient. And we realized that if we combine the versatility of horizontal AI with specialization of vertical AI, we can create very powerful AI system that will be both efficient and flexible. And in order to develop this efficient AI system, we need to introduce the overall machine learning development process. What we can see from here is a typical machine learning development process, which starts with a pre-processing data set and which follows with data modeling, model validation, and model deployment. But as you can imagine, that is not the case for vertical AI tasks. And in vertical AI tasks, at least the first step will be split into two parts: data collection and data labeling. And even when you do that and switch to data modeling part, you will still need to collect and label your data, and even during the model validation. And that turns this process into multiple iterations over again until you achieved the desired accuracy. Well, and the first challenge as we faced, as you can imagine, is the scarcity of construction drawing data sets. And finding these data sets, obviously, is not easy, which make our projects more challenging. And it brings me to my second key point: how to effectively collect and label these industry-specific data for architectural engineering and construction industry. And you might have heard about the recent paper that Meta published earlier this year, which called Segment Anything. And just for you to understand, they used, for training this model, they used over 1 billion of data points. And we have, in Autodesk, we have maybe hundreds of thousands drawings, which is still rich. And like, I promise you, we have one of the greatest data set in the industry, but that is not comparable with 1 billion data points. So that shows the significant magnitudes and difference between vertical and horizontal AIs. And because we work with the vertical AI and niche data, the availability of data is becoming a big challenge. And you really need to be creative to get your data, paying a lot of attention to trust and security of your data. And during this process, we created over than 5 different machine learning in order to collect the sufficient amount of data, starting from object detection and finishing with classification models. Well, but when you also collect niche data, the next step is to label it, right? And I remember a couple years ago, I volunteered as a manual labeler at the crowdsourced research project, which called Universe. And I needed to label a bunch of images with penguins and owls. And my 6-year-old niece at that time was proactively helping me. And she was thinking that is so easy adult task, so she can easily do that and like distinguish penguins and owls. And I agree, That task is very easy. And it is actually very possible to do in a different platforms and scale this labeling process. But as you can imagine, that is not the case for vertical AI task 2. When you need to label such kind of objects like truck systems or electrical switches, it's very difficult, especially if you don't have expertise in this domain. And of course, not everyone can do that. And some of these symbols might look very similar, but they can mean completely different tasks. And for resolve this problem, of course, we needed to work with domain experts who will help us with manual labeling, but that is very costly for sure, but at least we can be sure that we labeled our data appropriately. But since the manual labeling is not just costly, but also very, very time-consuming, we started to look for the possible optimizations using machine learning. And we created the model assistant labeling process using active learning to label our data automatically, which significantly speeded up our labeling process and reduced the workload. And here on this slide, a little bit different how it should look like, but okay. On this slide, I want to just show you the results, what we achieved using active learning there. We labeled in approximately 17 times more data, spending just 1/3 of the time. And you probably might ask me why we cannot use only active learning in model assistant labeling. And the answer here is model assistant labeling is less precise, and as a trade-off, you won't get that good quality as you have with manual labeling. But it might be seen the tolerance to the label quality if you hit the sufficient enough data per category. So, and that leads me to my next key point and how we developed our ML model for vertical AI tasks. Well, and on this slide, I want to illustrate how we combine the horizontal and vertical AIs. And let me introduce you to our universal machine learning workflow. The first, we start with collecting and labeled our input data, which is part responsible for vertical AI. And then we encoded our data, extracting the meaningful representations and features. And this step is very crucial, of course, because it can help us to capture the essential characteristic of the data. And that is a step which is responsible for horizontal AI tasks because we use some very common architecture. And on the next step, we started to measure the similarity of our embeddings, and which involves the comparing the encoded representations and measure the similarities, identify the patterns, relationship between our embeddings, and then as a result, we were able to predict to the user the top 5 main characteristics. And that is where the combination happening, where we can build our hybrid AI, which has everything, the versatility and efficiency. And for vertical AI tasks, it's very tricky to fine-tune your model too, because they train on very general objects, and when you start to work with floor plans and architectural drawings, that data have their own specific. And here data modeling actually requires a lot of time. And we did the fine-tuning, experimenting with the different backbones, weights and initialization, feature fusion, and loss functions. And that is the main characteristic that helps us to boost our model performance. As a result, we got the multiple machine learning models and make suggestions, but all the time we look into our models, we ask ourselves, is the user problem solved? And for doing that, to answer this question, we did internal testing as well as the customer interviews where we ask all the time how this machine learning model works and everything. And as I mentioned at the very beginning, we still continue label our data and collect more and more to make our model more or less biased. And here we come to the model deployment. And as many young professionals think that is the last step, when you train your model, it's done. Actually not. When we do the model deployment, it's not the end of your machine learning process. And after you deploy your model, and here I want to switch a little bit topic and talk about gardening. And I don't know how many of you gardening, but actually gardening is very similar to machine learning process. You need to plant your seeds first, right, and nurturing them to grow to the vibrant plants. But however, your process is not ending there. As the seasons change, you really need to water your plants and pruning them from the past. And that is the same happening when you develop your machine learning model. And here your process will turn into the loop. And after you deploy your model, you still need to maintain that. And I think I'm out of time, right? I have 2 more slides. Oh, I don't need it. Yeah, sure. So, cool. Yeah, I shouldn't run out of time, yes. If you have any questions, you can ask me after the presentation because I have a couple of more slides here. So, our model will turn into the loop, and which is called model maintenance. And once we release the feature, each interaction of the user with our feature becomes opportunity for us to learn and improve. And through powerful instrumentations, we can track the user acceptance of recommendations and which enables us to collect a lot of feedback and gain insights, what works, what doesn't. And this feedback helps us to identify the areas for improvement, allowing us to steadily enhance the user experience. And that is very similar to Facebook feed, which is regular update based on the user interactions. And that is what we do. However, we don't want to retrain our model every time over again because it's very costly, time-consuming, and we won't be able to do that pretty regularly. So, and that is why we embrace the power of incremental learning. And incremental learning involves the continuous updating and refine your model based on the newly acquired data. And by incorporating these iterative approaches, we can fine-tune our system, making it more accurate, efficient, and user-friendly over time. And finally, in conclusion, I want to say that machine learning workflow represents the captivating journey, starting from data collection and finishing with model maintenance. However, I want to say that intelligence workflow transformation is not merely about technology, but it's also about addressing the user needs. And in order to build the efficient machine learning model, you always need to think what will help your user or not. And by actively engaging with the users, gather feedback, and iteratively refine your system, you can build your powerful ML solution and truly enhance the user productivity. And as we continue our transformative journeys, we always need to think that how it's important to prioritize the user-centric design and make sure that our intelligence tools help our users and don't confuse them. And I think that's it of my presentation. And Yes, if you want to reach out to me, please feel free to come over our breaks. And that is my contact information. Thank you so much for being here today.